Hey, welcome back. This is Miss Glink. Today I'm going to show you how to add and subtract mixed numbers. So it's pretty simple once you get the hang of it, but I'm going to show you something a little smaller to start off with. So if you have 1 2/3, and just to remind you, a mixed number is when you have a whole number that's attached to a fraction. So if you have 1 2/3 plus 2 1/3, the first thing I do is I just focus mainly on my whole numbers. So I'm going to ignore my fractions for now. So I'm going to circle my two whole numbers, the 1 and the 2. I'm also going to circle my plus sign. And the reason I do that is because it helps me to remember that I'm adding and not subtracting. So I'm going to simply add 1 plus 2. Well, that's easy. That's 3. So I have 3 wholes. And then I'm going to focus on my fractions. Now remember, we're still adding. So I'm going to add my 2/3 plus 3/3. Oops, I didn't mean to do that. I'm a little bit ahead of myself. I'm going to add my 2/3 plus 1/3. Now remember, it's always best to, when you're adding and subtracting fractions, to add them horizontally or straight across, because if you put them vertically or straight up and down, it can get really confusing. And by putting them horizontally like this, it's easy to see how many you need to add in the numerator. So I'm going to add my numerators. 2 plus 1 is 3. And let's fix that 3 a little bit. 2 plus 1 is 3. And remember, we don't do 3 plus 3. I'm going to show you why. We have to keep our denominator the same. So over here in this little box, I'm going to show you, if we have 2/3, shade in, that's 2/3. This is a picture of 2/3. So then we have to remember, when we add and you're showing pictures, you need to make sure to show the same shape for both. So if we add a 1/3, then you notice that both of these shapes have split into the same number. They have equal number of pieces, and they're also the same size pieces. Remember, that's important in fractions. So when I add, the total number of pieces has not changed. We still have to have 3 pieces. It's like a candy bar. If you start with 3 pieces, you can't have a fraction that's equivalent, or not that's equivalent. You can't have an answer that has a denominator that's different. We have to keep them the same. So if we take our 2/3 plus another third, that means we have really counted 1, 2, 3. We've used up 1, 2, 3 pieces. So actually, we have 3/3, which is the same thing as 1 whole. So our fraction answer ends up being 3 3/3, which actually equals 4, because if we have 3 3/3, it's the same thing as saying 3 plus, remember, this is equal to 1 whole, 3 plus 1 equals 4. So we're going to try this on a different fraction. So let's do 4 and 3/5 plus 3 and 2/5. Well, if I use the strategy I had before, I'm going to add my whole numbers. 4 plus 3 is equal to 7. So I know that my answer has a 7 as a whole number. So now I'm going to look at focus on my fractions. Remember, we're still adding. 3/5 plus 2/5 equals 3 plus 2 is 5. And as you remember before, we have to keep our denominators the same because the total number of pieces that we started with has not changed. Now, look at this 5/5. You notice anything interesting about it? Well, you're right. 5/5 is equal to 1 whole. So really, we could change this fraction into 1 whole. So it turns into, we have 7 plus 1, which equals 8. That would be the simplest form. I mean, you can say 7 and 5/5. That answer would not be wrong. But if you wanted to put it into the simplest form possible, it's the same as 8. Let's check this out with subtraction. So we're going to try subtracting subtracting mixed numbers. So let's do 10 and 5/8 minus, let's do 6 and 1/8. So I notice this time I'm subtracting, so I'm circling that sign. Again, start with your whole numbers. There's no reason to confuse yourself with trying to do it all at once. So 10 minus 6 equals 4. Cool. So now I have my whole number 4. But we don't want to forget about these fractions. So we have 5, I meant to do that in a different color. So we have 5/8 minus 1/8. So I'm going to put that down here. 5/8 minus 1/8 equals 5 minus 1 is 4. And 8 minus 8, now be careful, we don't want to put 8 minus 8 as 0 because we still have 8 pieces that we started with. That has not changed. The only thing that's changed is the total number of pieces we're left with, and that's your numerator. So we still have a denominator of 8. Okay? Let me show you a picture of what that would look like if we were to draw it out. So it's always easier to see it visually to really kind of understand why. So let's just say I'm going to split this into 8s. I always like splitting these into 8s because it's easier since it's a even number. So I start with 5/8. So I'm going to shade in 5. 1, 2, 3, 4, and 5. But now it says I have to subtract 1/8. So this is what I do. And if you have a different way of doing it, that's completely fine. I'm going to take my black and I'm going to put an X over one of those. Now, how many pieces do you see are left over from that original amount? Well, if I count it, 1, 2, 3, 4, I have 4/8 left over. And check it out. That's the same exact fraction that we have over here. So that is why, a visual way to see why we have to keep our 8 in the bottom, because we still have 8 pieces in the whole. So our answer to 10 and 5/8 minus 6 and 1/8 is 4 and 4/8. Or you can also say this is, I ran out of room and I didn't want to confuse you, so I went to a new slide. 4 and 4/8. There is something special about 4 and 4/8. It's just, this is a nice to know. I know that 4/8 is also equivalent to 1/2 because 4 times 2 equals 8. So another way I could write 4 and 4/8 is 4 and 1/2.